So I hope AWS CLI is installed in all of your machines by now. Okay, so what we will be talking about today is in the first part we will do some basics and live coding, and then in the second part we will have a tour of how things are being deployed or how infrastructure is being managed in the production of our career link system. In the demo, we will be building a simple EC2 web server with security groups configured and in a modular fashion. So let's talk about what is infrastructure as code. Traditionally, if we were using AWS, what the deployment or infra management process would look like was we would log in, we would click through the AWS console here and there, and then we would, after a long time, we would be having our infrastructure set up. But that was very error prone and time consuming. And if me as a infra manager did that thing, it wasn't replicable by another person because it was all click and GUI based, and also importantly it had no version control. But now with infrastructure as code, what we can do is we can define infrastructure in code just like we write our applications, and hence that can be version controlled in Git. And since it is a piece of code, that same code can be used by multiple people, and we can have repeatable and replicable deployments. The major tool for the infrastructure as code is Terraform, and it's important because it is cloud agnostic. It supports hundreds of providers. But there's a catch here. It's not necessarily true that with a single code, the same code will work for AWS and GCP itself, because AWS and GCP have different namings of the instances. For example, for AWS, we use AWS instance EC2, whereas for GCP it would be something else. So even though the code base is same, even though the code is same, we would have different modules for AWS and GCP, but the commands and the toolings would be the same. In Terraform, we do not say how to do things, we say what to do, and that's declarative. Terraform provides state management that can be done locally or using the cloud itself. One of the very important features of Terraform that I feel is plan before apply. We write code, and when we say Terraform to plan, when we ask Terraform to plan, it shows us what things are being changed. Like what are the things, what are the components that are being added, what are the components that are being removed, and what are being replaced. And Terraform has a large ecosystem of thousands of modules which we can reuse. So the basic workflow in Terraform looks like this. We first write the Terraform file and then we initialize it. During the initialization, we initialize modules, providers, and all the plugins that we use in our code. Then, like I mentioned, we do the planning, how the deployed infrastructure would look like, make sure everything is right, everything is correct, and then we apply it. And this is the phase where the actual infrastructure is set up, and after applying we can manage our infrastructure, we can update or destroy the infrastructure. We will be using these commands frequently afterwards, so I'm not going with that for now. Okay, so let's get started with live coding, and for that I would like to share a couple of things with you. So this is the command that we need to do. We first create a .aws directory, and inside AWS, using your code editor, create credentials file. You just open the credentials file inside .aws in the home directory, and then you just paste the code that I sent. Okay, let's move on. Now, I would also like to share with you the code snippets that we will be using throughout this session. Please have this open in one of your browser tabs, and we will frequently be referring to this. Okay, so what I'm going to do is I'm going to cd into a temp directory. Okay, so I have changed my directory into temp. I will now create a directory for where we will be doing all of this demo, and we will start from the clean slate. Yeah, okay. So one more thing is, for the sake of ease, I tend to make file so that I can use shortcut for commands. So I'll just do that. That will be needed for viewing the EC2 instances that we have created. So create a makefile and just copy this command. This is actually an optional step, but I would recommend you to do this. Okay, so if you have created the makefile, then let's try one command. Make EC2. This will let us look into see the EC2 instances in this account. Now let's get started with our first piece of code. So in the code snippet that I shared with you, copy the let's have a look at the stage one, the main.tf, copy the contents to the main.tf file in that directory. So I'm creating main.tf and copying the code. And if you have already done that, please make sure that in the tags section at the end, make sure to replace your first name with your name, so that we can, when we view the instances in the AWS, we will be able to see who have created the instances. Okay, so should I move on with explaining what's going on here? So
Yes.
this is the first and the important section where we define the providers for Terraform. So this is common for all the deployment, and this is the section where we define our providers. And for now, we have only AWS provider, and we define it like this. And the source and the code for the AWS will be loaded from HashiCorp/AWS, which is a Terraform specific repo, and we use a particular version for this, and this represents what is the required version for Terraform, right? So we have defined our AWS provider, and it's now time to configure the AWS provider. So for AWS provider, we will be using the profile tf-demo. Remember what we did in our AWS credentials folder, right? So with that, there we copied the credentials that I provided, and it was named tf demo. So that is the key that will be used under the hood. So this part is almost common for all the things that we will be doing, because this is agnostic of the resources that we'll be using. So now this is the section from line 16 where we define what resources do we want. So the resource is always defined like this: the resource command and what kind of resource and the name for the resource. Since this is AWS instance, and inside this section we will have all the configurations for that particular instance. So since this is AWS instance, we will have configurations related to AWS. So for example, what does this AMI mean? So AMI means Amazon machine instance or machine identifier, and this is the identifier for a Linux machine with Ubuntu 22.04 installed. And then we define instance type. The instance type is t2.micro. This is the one of the smallest instances available in AWS. And of course, the tag for the instance, demo server, and your name. So is there any question so far?
So Vivek, this like when you say the resource AWS instance, so isn't this the like a template for any other provider as well? Let's say we want to do it in GCP, right? So you basically will have to write that resource, and then there what the value would be instead of AWS instance, it will be different.
Yeah, it will be different.
So the reason I was asking was I thought this is like the vendor agnostic template, right? It should use, if you give a specification, it would be able to translate across any vendor like Google or the Amazon or Microsoft, right? So but if you have to specify exactly it's the AMI Amazon instance, what's the abstraction?
The abstraction, yeah, that's a very good question. And I think it's the question that arises when we first use Terraform, and when we have really high hopes for Terraform, because it's infrastructure as a code and it should be able to abstract the providers. But yeah, like I mentioned earlier in the slide as well, it's how Terraform works, and it's the limitation as well. So basically what it allows us is to have the code managed with same commands and same tooling, but the actual configuration for the instances or resources in different providers will be different, and that should be handled using different, say, okay, we would be making different configurations or different folders for different providers. So yeah, that's how it works with Terraform.
So basically, like if I ask in another way, so Amazon has something called a cloud formation template, right? So it just has its own the template just like this, but the Amazon is specific. And Google has similar template, I'm sure, like Azure. I have not used Azure. Azure has similar template. So maybe my expectation was it will be able to translate the common thing into some of those templates. So this is just another layer. Is it a layer or it's another language? So I'm a little bit like there is no translation happening. It
No,
is
there is maybe I can talk about that little bit from, at least from the Azure perspective, right? So
okay.
even after this, when if you want to configure to deploy, like let's say in case of Azure, it's like it's called virtual machines, right?
Right.
So even that has so many different variations, and like there's so many things you have to do to deploy even one single machines. So I think if I understood correctly, Terraform actually, like if you say resource, let's say virtual machine, and it is specifically for Azure, I think it will
Mm.
do the translation down under the hood, and it will create Azure template and do the deployment of that for you. So I think it kind of provides some level of abstraction, but I think you're right. You still need to be aware of like different clouds and
Yeah.
different nuances
Yeah.
there. Yeah.
Yeah, that's helpful. No, I've not used Terraform, so I have to use like limited knowledge of the cloud formation AWS. But yeah, no, this is good. Thank you. Carry on, Vivek.
Okay.
But yeah, I had a question on that resource. So does the instance actually have a name that you can refer to down the line, or do you refer to that particular instance as the name you specify in the tags? Or how does it work in
So
AWS?
yeah, that's a good question. So this name is for the Terraform to refer to the instance by itself. So for example, if later on we change something here, okay, let's say we make HT2 Medium, then it will know that okay, this demo instance is changed. So this is for Terraform, and this tag is for the AWS, and this is where this tag is what that appears in the EC2 instance.
Okay.
Okay. So now that we have created a Terraform file, let's do this. Let's run Terraform init, because we haven't initialized any providers yet, so we cannot do Terraform plan. If we do
Wait, do I
that,
need to install Terraform separately?
oh yes, you have to install Terraform as well.
Thank you.
Okay, so yeah, like I mentioned, it doesn't allow us to plan because we haven't initialized anything here. So let's first do Terraform init. Okay, now that we have initialized, we can run Terraform plan and see what changes are being done. Okay, so the summary is we have one thing to add, nothing to change, and nothing to destroy. So what is being done? There are a lot of things, but we can get the general feel for what's being done. So the plus means we are creating, so we are creating this resource. The AMI is this, and all of these values which are AWS specific will be known after applying the Terraform, applying the code, including the instances ID and public IP as well. So we will know the instances public IP after we apply the Terraform. Okay, so if everything is good, then we can run Terraform apply. Okay, so we have successfully added one instance, and here comes the use for the make EC2 now. So we have successfully created our instance in AWS. Okay, now let's destroy what we have created. And if you notice in the EC2 command, the state is running. So if we destroy it now, it's gonna take some time, but we will have it destroyed in a while. Okay, so while it is being destroyed, let's move on to another section. We completed this. Let's have a look at variables. So variables, just like in programming, variables are used to reduce errors and reuse some things in different places. For example, if okay, let's have a look at in the example itself. For variables, what we can do is, okay, so in the stage 2 section in the gist that I shared, let's copy the content into variables.tf, and I will describe it as we go. So once you have copied that in the directory, let's go to main.tf and refer to let's refer to reason with the variable var.aws reason. And for instance type, if we have done that, let's see what make plan does.
So
Sorry, Terraform plan.
did you actually add something to make sure this file refers to that new file? Is it automatic?
Yeah, the variables, that's a good question. Variables.tf is also read automatically. So if we let's do this, make plan. Okay, so what's happening here is, since we define the default values for the variables, it did not ask anything and just use the default values directly. So however, if we want to modify the variables, then what we can do is create another file called terraform.tfvars, terraform.tfvars, and let's define AWS instance to be T2 medium, let's do T2 micro, and what else, reason to be bassist one, and also let's go one step further and add username Vivek, and let's define that in variables.tf. So variable username and type, let's not add any default value for that. So basically we define variables in variables.tf, which will be picked up automatically, and if we want to override the default values in variables.tf, then we define those in terraform.tfvars. So then let's open the main.tf file, and in the place where we have used our name, let's replace it with $var.username. Okay, so let's see what Terraform plans for us. Okay, so we have our username added here, and the rest of the values we cannot see the difference because those are the same as when we hard coded those. Previously we had in the tags, we have our hard coded username. So what we want now is to have this configured from the variable. So what we do is var.username, right? So for this to work, we need to do two things. First, in the variables.tf file, we need to define this as a variable, right? So the variable's name is username, and we just put some description and its type. Its type is string. If we provide, we can also provide some default value here, but let's not do that. And once we have defined the variable here, we can set the value for that variable in terraform.tfvars file. And for all the steps, we will just do Terraform plan so that we can see if everything compiles and everything is as expected or not. We will do apply only after we add another resource called security group. So yeah, we can now see the changes. Let's move on to the next part. We did the variables, and just a short information on variable. It has it allows us to define variables of different types like string, number, boolean, a list of string, and map. And yeah, so there's some precedence for variable as well. So it first looks for the variables in the CLI flags. There's many ways we can define variables. It can be in the environment variable. For example, if taking into consideration our username, if we set our environment variable to be tf_var_username equals this, then this would be picked up by the Terraform. And we can also define variable in place in the same main.tf file as well, but that is not recommended. And as this mentions, terraform.tfvars is the default var files which will be read automatically. Okay, so far we have only added a single resource, that is AWS instance, but that is not enough generally. So let's go ahead and add something called security group. Security group is kind of a firewall for the instance that we create in AWS, and it has rules for what traffics to allow coming into and what traffics to come out of the instances. So we are going to add a security group that allows SSH and HTTP traffic to pass through. For that, let's go to the snippets file and move on to stage 3, and let's just copy over the main.tf file and replace what we have in the file so far. So from the gist in the stage 3, we just copy the content of the main.tf file in the snippet and replace whatever we have in our main.tf file. Okay. So the first, if we have done that, let's go through the code. The first section is almost the same. It's the same, the Terraform definition and configuring our provider. Now we are doing something new called security group, and this is how we define security group in AWS. Previously, for EC2 instance like t2.micro, we did AWS underscore instance, and then we provided the name, right? So for security group, what we do is AWS underscore security underscore group, and then provide the name for that group. And the description, we are allowing HTTPS and HTTP traffic into the instance. And this is how we configure HTTPS traffic. So ingress stands for what traffic coming inwards to the instance. We allow from 443, we allow to 443, and this is the main important part. So what this CIDR block indicates is that we are allowing HTTPS traffic from anywhere. So for instances that need to be accessed from only from the instances within that AWS region, we would use the network CIDR or the private network CIDR for that particular instance. And something similar with HTTP as well. We are allowing requests from port 80 to port 80, and we are allowing traffic from anywhere. Similarly, we define the configuration for SSH, it's port 22, and for now we are allowing it from anywhere. Generally, the practice for security group, or put simply firewalls in AWS instances, is to allow all the traffic outside the instance, because the threat mostly exists when the traffics are inward and not outward. So for outward, we generally allow all the traffic to all the to anyone who have requested.
So
So
what
this,
is the default behavior if you don't specify any NSCs? Is it like blocking everything or allowing
yeah,
everything?
it blocks everything. So we have to it's a security measure that we have to like whitelist every port that we want to have access to. So for example, if we try to say SSH into the instance that we created earlier, we would not have been able to access it. So this is the configuration for the security group. Now we need to use that in the AWS instance. So we are now at the AWS instance block. We define the resource just like how we defined it earlier. Resource AWS instance and the name. AMI is the same, and instance type, we are using the instance type from variable, and this is the new configuration. In this configuration, VPC stands for virtual private cloud, and what security groups are we using? So basically, we are using the AWS security group. This is the resource type and resource name and the attribute of the resource. So if we go up and see, this is the resource type AWS security group dot web, and when this resource is created, it will have some ID associated with it that will be known after applying, and we just use that here. And this is the basic tag that we use for AWS resources. Another thing that we did not discuss earlier is the output. So for example, after we apply, then we can have the apply command present to us various things or various IDs or maybe public IPs for us. So here we have defined an instance ID output. This is the output that comes from after applying the Terraform apply command. So the value of instance ID is the AWS instance, that is the resource type, resource name, and ID. So this will display the instance's ID after we run Terraform apply. Similarly, we would also want to see the public IP of the AWS instance, and this is how we output it. This output, this can be any name, description can be anything, but the value should match the resources that we have defined. So for example, here AWS instance.demo.public IP. So the thing is, we need to know beforehand what attributes are associated with a particular AWS resource. For example, for AWS instance, there are attributes like ID and public IP, right? So similarly for security group also, we want to display its ID, and this is how we do it. AWS security group dot web, which is its name, and dot id, which is the attribute of the security group. Okay, so let's do Terraform plan and see what it shows us. Okay, so if you had noticed earlier in the plan, it said want to add, and that referred to the AWS EC2 instance that we defined. But now, as we expect, we have two instances or two resources to add, and let's see what those are. So AWS security group dot web will be created, and these are all the configuration that we did in our code. And similarly, AWS instance dot demo will be created, and these are the attributes. Let's see what's there for the security group. Yeah, security groups also will be known after applying, and these are the tags we defined. So let's do Terraform apply. Do you want to perform these actions? Yes. Let's see the demo. Web SC already exists for VPC. Okay. Actually, I created it earlier. So let's do SC1. The thing is, when we all are doing the same thing, when we all are following the same command, this is what happened. So in order to disambiguate, we can just do var.username, so that we will have different ones for each of us. So let's do.
And how is that environment defined? Is that
We
default or is it in the, where is that defined? Bar dot
we
environment.
have defined in the variables.tf. We just copied over. So
Oh,
yeah, this
okay.
was done in the previous step.
Okay, got it.
Yeah. So in order for everyone to work, we need to somehow make this security group name unique. So I'm just adding my username here. Let's see what's there in the AWS right now. Terminated running demo server. Okay, demo server. Let's see. In the AWS instance also, let's add username. We kind of missed it when we copied over, replaced the previous content. So if we do this, then it will be easier to see who has deployed the infra. So let's do Terraform plan. So these are the outputs that we defined, which will be done after applying. And to add, this looks good. Okay. Okay, so our resources are created, and just like we defined in our output section, the instance ID is this, and this is the public IP for the instance, and this is the security group. Okay, so let's try, I'm going to try to access that instance. All of you might not have the private key to access, but I will just, for the demo, I will be showing that I'm able to do SSS there. If we want to see the output again, we can just do Terraform output. Okay, so this is n. Yeah, I am in the machine. Okay, so this is fine. Let's everyone please do destroy now. Now that we have done completed this step, this stage.
I want to ask one question.
Yes, Arman.
What if we lost the TF state file, Terraform state file?
Yeah, that's a good issue. I mean, that's a good question. When we lose the terraform.tf state file, we need to ask Terraform to refresh. So there's a command called terraform refresh that that fetches the information from the AWS and populates the state file. But having said that, the best practice for dealing with state files is we don't use them locally. We store them in cloud so that the same state can be shared by multiple users if needed. For example, one team might have two DevOps engineers, and they might need to work remotely, and it's very error prone to use local state files. So the general best practice is to use a cloud-based state file, and also on top of that, the cloud-based state file will be stored in S3, and also on top of that, for better security and to let not both of those modify the file single time, we generally, the best practice is to use DynamoDB that allows to have locks on those state files. So let's have I don't think there's anything in the state file because we have just destroyed everything. Terraform.state. Yeah, so basically if we had something up and running, then we would have this resources section populated. And now since we are using the local state, it's everything is in locally. But if we look at our production system, the setup is in the S3, so the state is in the S3.
Visit careerlink.ai to explore a curated list of powerful AI tools, all designed to meet your specific needs. Dive into our live circles for a deeper, more immersive AI learning experience where you can truly deepen your knowledge and skills. Don't forget to check out our prompt library, a collection of carefully selected prompt books crafted to guide your learning journey. So, what are you waiting for? Start mastering AI today and take your career to new heights. And remember, make sure to subscribe to our channel for more content like this and stay updated.